one of the problems with fractions is that it's very difficult to tell which one is bigger than another. Now here I have a very accurate diagram that tells me, lets me compare 7/9 and 4/5. It's not entirely obvious, but we can just about see that 7/9 is a little bit smaller than 4/5. If I were to draw them as fractions of a pi, then we could see that 7/9 was a little bit less. This is not simple, and if we don't have time to draw a diagram, we need a way of working it out, and the only way is to make sure that our denominators are the same. So here, my lowest common multiple of 9 and 5, the first number in both the 9 and the 5 times table is 5 times 9 is 45 in this case. There's no shortcuts. So what I need to do is multiply both the top and the bottom of this side of this fraction 7/9 by 5 over 5, the number from the denominator here. This is just a big one. I'm multiplying by 1, so I'm not changing the size of the number. I'm just changing how it looks. 7 times 5 is 35. And 9 times 5 is 45. So 7/9 is the same as 35/45. And here I need to take my 4/5, and I need to also get 45 on the bottom. So here in the denominator, I multiply top and bottom by 9. Now 9 divided by 9 is just 1. So I am multiplying by 1 here. I'm changing the way the number looks, but I'm not changing its size. This gives me 4 9s are 36. And 5 9s are 45. So I can now compare 36/45 and 35/45, and we can see that this one is smaller than this one. Ordering fractions. This means to be able to put them in order, which is bigger. If they have the same denominator, it's easy just to use the numerators to put them in order. Otherwise, to order fractions, you need to know about equivalent fractions. So if they've got different denominators, we need to have the same. Remember the egg timers, remember the lowest common multiple. The lowest common multiple of 2, 3 and 5 is 30. So 1/2 is 15/30, a third is 10/30, 3/5 is 18/30, 2/3 is 20/30, 2/5 is 12/30. Now we can put them in order. 10/30 is the smallest, 1/3, then 12/30 is the next smallest, that's 2/5, then 15/30 is a half, then 18/30 is 3/5. And we're left with 20/30, and that's what we do. Ascending means going up, getting bigger, like going up the stairs. Descending means going down and getting smaller. So we're going to put these in ascending order. What number is in the 2, 4, 5, 10 and 20 times table? We need our common multiple, probably the smallest one. And 20 will do. So turn them all into 20ths. A half is 10/20, a quarter is 5/20, 3/5 is 12/20, 3/10 is 6/20, and 11/20 is 20ths. Now order them ascending. The smallest is 5/20, then 6, then 10, 11, 12, and then replace them with the original fractions. So 5/20 is 1/4. 6/20 is 3/10, 10/20 is a half, 11/20 stays the same, and 12/20 is 3/5. So what denominator do we need now? Something in the 3, 6, 5 and 12 times table is 60. So 1/3 is 20/60, 4/6 is 40/60, 2/5 is 24/60, 5/12 is 25/60, and 5/6 is 50/60. Put them in order. 20 goes first, then 24, 25, 40, 50, and replace them with the original fractions. 20/60 is a third, 24/60 is 2/5, 25/60 is 5/12, 40/60 is 4/6, and 50/60 is 5/6. So here we could try and compare some fractions. When I look at this number line here, we have, ignoring this little dot here, 1, 2, 3, 4, 5, 6, 7, 8 divisions. So these are eighths. So I need to think of my fractions in terms of eighths. This, I need to multiply top and bottom by 4. 2 4s are 8 and 1 4 is 4. So a half is the same as 4 eighths. Here I need to multiply top and bottom by 2 to get 8 on the bottom, and 2 3s are 6 on the top. This I need to do nothing, and here I need to multiply top and bottom by 2 to get 8 on the bottom and 2 on the top. So here a half is 4/8. 1, 2, 3, 4. So this would be a half. 3/4 would be 6/8. 1, 2, 3, 4, 5, 6/8. So 3/4 would be here. 5/8. 1, 2, 3, 4, 5, 6. Well, 1, 2, 3, 4, 5/8 would be here. That's the first Chris. And finally, 1/4 is 2/8. So this would be over here. Correct. Let's have a look at another one. So in this example, we have 1, 2, 3, 4, 5, 6 divisions. 2/3 would be 4/6. 1, 2, 3, 4/6. 1/2 would be 3/6. 3/12 would be, well, between 1/6 and 2/6. It would be 1.5/6. So there's the point to move that to. And 5/6, 1, 2, 3, 4, 5, 6. Here. And that's correct. For this example, notice that we have 2 here. So number 1 must be over here. And now we then need to look at these. Here we're looking at top-heavy fractions for the first time. So here we have 1, 2, 3, 4 groups, and 1, 2, and there must be another one there, 4 groups. So these are quarters. This is 3 halves. Well, here's 1/2 and another half. So this must be 3 halves, and 3 halves must be the same as 1.5. This is 3/4, 1, 2, 3, and 4. So this moves here. This is 8/4. Well, there's 1, 2, 3, 4, 5, 6, 7, 8. 8/4 must be the same as 2. And if I divide 8 by 4, I do get 2. And finally, just 1/4. That's over here. Let's check that. And those are correct. So, to arrange these fractions in order, we really need to have the same denominators. We've had halves, 25ths, and hundredths, and tenths, and the biggest number on the bottom is hundredths. So we need to think of how big is a half in hundredths. Well, 2 goes to 250 times. So if I multiply top and bottom by 50, I will get 50 over 100 here. 25 goes into 104 times. So I need to multiply top and bottom by 4 to get 16 hundredths. This is already in hundredths, and here I just need to multiply by 10 to get the next largest number? 30. This is 50. Finally, this is 87. So some extension questions. Can you find a number between a third and a fourth or a quarter? How about another one? And for an extension, how about a decimal number or a percentage? And can you find a number between 1/3 and 2/7? And how about another one? And for an extension, how about a decimal number or a percentage?